Welcome, welcome. This is an add-on section for topic 9. We're just going a little bit into some of the operations with square roots. It turns out that there's no place in the integrated series that teaches this outright. They just kind of include it in some of the lessons going along. And I think it deserves its own special attention. So today we're going to be talking about 3 things, namely with square roots: multiplying, squaring, and something called rationalizing the denominator. So example 1, simplify each expression, leave all answers exact, which means in radical form, don't turn anything to a decimal, and rationalize all denominators. When multiplying, we're going to multiply rational parts together and square root parts together. Let's break this down a little bit here. Okay, if I've got something like 3 square root 5, the black part here is a square root. Now, sometimes I have roots with a different index, and that might look like this. Like this is a cubed root. We are going to get into this much more in other classes. When it doesn't have a number in this spot, it's automatically assumed to be a 2. Okay, so it's a square root. That's what that symbol means. This number here underneath the radical is called the radicand. All right, and this, oops, not T, D, radicand. This is my, all of this together is my irrational number. So let's have a reminder of what is a rational number, what is an irrational number. A rational number is let's change this. A number that can be written as a fraction of 2 integers. Right? So when I have some number, I don't know, like 7 over 3, right? The top is an integer, the bottom is an integer, or negative 7 over 3. That is a rational number. It can be written as any fraction of 2 integers. An irrational number is everything else. And an irrational number will usually look like the square root of something that's not a perfect square. Okay. So here is my rational number. So some vocabulary to kind of go over there. In this first example A, the square root of 6 times the square root of 15. I have two irrational numbers. I'm going to multiply them and simplify. I'm going to multiply irrational parts with irrational parts. Now here, you can't really see it, but the number in front of these radicals would be 1 and 1. So when I multiply this, I get 6 times 15, and I can write that all underneath the one radical. And 6 times 15 gives me 90. Now I have to simplify that. So we've been getting some practice lately with our factor trees. And you can use different numbers to multiply to get 90 and work your way down. But at the end, you should have 2 times 3 times 3 times 5. When I'm taking square roots, remember I'm looking for pairs because 3 times 3 is 9, and the square root of 9 is 3. What's left inside is the 2 and the 5, so I multiply those back together, and I get a simplified answer of 3 square root 10. For question B, my big difference here is on one of the terms, I have a 2 in front, so I have 2 square root 10. I only will multiply rational parts with rational parts and irrational parts with irrational parts. So I'm going to multiply the 10 and the 18 together. And I would multiply 2 times, well, there's a 1 in front of here, but I wouldn't really write that, right? I would just have 2. So the 2 can stay there and hang out. And this is the square root of 180. So the factor tree for 180. And I know that I'm going to whiz through these factor trees a little bit. We've gone over them and over them. I don't want to spend my time teaching this. If this is a skill that you are not proficient at yet, please ask for additional help or find some additional resources to get good at these factor trees. That's still a skill that you're working on honing. I've got 2 2s. I've got 2 3s and a 5. I've still got this 2 in front. And now as I go through, I have a pair of 2s. So I bring it out. I have a pair of 3s. I bring one out. And I'm left with a 5 inside. So all said and done, 2 times 2 times 3, let's see, 4 times 3 is 12. I'm left with 12 square root 5. All right, so the only difference with C is now I have 2 whole numbers, so playing kind of the same game here. So I've got a 2 and a 3. I'll multiply those together, 3 times 2 on the outside. And then the numbers that are under the square root, they'll stay under the square root, and I'll multiply those together. In my first problem in A, I use this little dot. Let me use my pointer here. I use this little dot to signify multiplication. Here I used 2 sets of parentheses. Here I used 1 set of parentheses, but it has the same effect. So just showing different ways that you could see these problems look. 3 times 2 gives me 6. Inside my radical, I have 48. All right, another factor tree. So when I write out all the factors of 48, this. And see if you can finish that on your own. I'm just going to pause for a few seconds, see if that makes sense, if that's reasonable. So I have the 6 outside. Pair of 2s gives me a 2. Another pair of 2s gives me a 2. Now, it is possible that, and this isn't the case here, but what if I had taken out everything I could and there was nothing left inside? If I have nothing left under the radical, then the radical just falls off. It's gone. And that's okay. Oh, let's see. So that's 24 square root 3. So if you're left with square root of, and there's nothing underneath there, just drop the square root. It happens. I don't have an example of that here, but there's no possible way I could have an example of every type of problem. So we're just rolling with it. D and E may catch your eye. I've got something squared here. Before we get nervous about seeing something to an exponent, remember that raising something to an exponent is the same as multiplication. This question here, the square root of 9 squared, remember that the square root of 9 squared just means the square root of 9 times the square root of 9. And I suggest you just rewrite it just like that. These are both underneath square roots, so I'm going to multiply what's inside to get the square root of 81. You might feel inclined to start doing the factor tree here, which you totally can, but I already have memorized what the square root of 81 is, so I'm going to save myself the work. Oh, what's the square root of 81? 9. See? No radical. Now let's say you forgot that for a minute and you start doing your factor tree. And then you write that you have the square root of 3 times 3 times 3 times 3. A pair of 3s, I bring one out. A pair of 3s, I bring one out. This is that situation I was just talking about where there's nothing left under the radical, so the radical just falls off. This answer is 9. Let's just look at that from another perspective. Squaring and square rooting are inverse operations, right? Just like adding and subtracting. If I add 5 and then subtract 5, I get back my original number. If I square something and then square root it, I get back my original number. So let's take a look at E. 2 square root of 5 all squared. So I have 2 square root 5 times 2 square root 5. So I'm going to multiply the real parts. I have 2 times 2 on the outside. And then on the inside, I have 5 times 5. 2 times 2 gives me 4. Square root of 25. Oh, what is the square root of 25? That's just 5. So my final answer here is 4 times 5, which is 20. Hopefully this is not brand new. You've probably been exposed to this in Math 1 and a little bit in Math 2 as well. You may not receive formal instruction on it again, but there's kind of some basics on multiplication and squaring with square roots. Down here in rationalizing the denominator, this skill we could really widen and talk about this in a lot of circumstances. I'm just going to do a few of the most basic problems here to give you an idea of what it is. Rationalizing the denominator is a skill we're going to use really lightly in this class. I just want to give you some exposure to it because when you get to the unit circle in integrated math 3 and pre-calculus and trigonometry, any of those classes, it is really important for that subject. So I'm just going to give you a little taste. Rationalizing the denominator means I want to make the denominator of a fraction a rational number. You'll notice here for these examples, f, g, and h, right? On f, I have the square root of 7 on the bottom. That's the denominator. On g, I have the square root of 2 in the denominator. On h, I have a square root of 3 in the denominator. I want to manipulate these fractions to come up with an equivalent fraction where there's no radical in the denominator. We're going to do this by multiplying the numerator and the denominator by the radical in the denominator. So check this out. Here we go. Step by step. Problem F. 8 divided by the square root of 7. Where's the problem? The problem is I have a square root of 7 on the denominator. What I'm going to do to get rid of that problem is I need to multiply the denominator by the square root of 7. I'll show you how that goes away in a minute. But in order to keep a fraction the same, I have to multiply the numerator and the denominator by the same thing. Right? If I have a half and I want to multiply the bottom by 3, if I just multiply the bottom, then it's not equivalent. I have to multiply the top by 3 also, right? We know that 3/6 is the same as 1/2. Same thing here. I can't change the fraction. I'm writing an equivalent fraction. What that gives me is on top now I have 8 square root 7. Right? One's on the outside, one's a rational number, one's an irrational number. So 8 times the square root of 7 is just 8 square root 7. There's an imaginary multiplication sign in between those. And then on the bottom, I get the square root of 7 times 7, which is the square root of 49. And what is the square root of 49? 7. By taking the square root of 7 and choosing to multiply by the square root of 7, I'm essentially squaring it, which gets rid of the radical and just leaves me with 7. This is my final answer. People often feel inclined to simplify these 7s. One of them is in the radical, one of them is out of the radical. They are not like terms, like kind of numbers. The numerator is a rational number. The numerator is an irrational number. The denominator is a rational number. You cannot simplify. I'm going to write that. Cannot simplify the 7s. That way, when you look back on your notes, you'll know that we did that on purpose. Cannot simplify the 7s. Okay, so I start again. G, 3 divided by the square root of 2. What's the problem? The problem is I can't have a radical or a square root in the denominator. How do I get rid of that problem? I get rid of it by multiplying it by itself. Whatever I do in the denominator, I do in the numerator. So on top, in the numerator, I'm left with 3 square root 2. And in the denominator, I have the square root of 2 times 2. Which is the square root of 4. And what is the square root of 4? Oh, that's just 2. To reiterate, you cannot simplify those 2's. One is in a radical and one is not. H is ever so slightly different. 5 divided by 2 times square root 3. What's the problem? The problem is square root of 3. So I'm going to multiply the bottom by square root 3 and the top by square root 3. That leaves me with 5 square root 3 divided by 2 times square root of 3 times 3. 3 times 3 in my denominator becomes 9. What is the square root of 9? 3. Now on the bottom, I have 2 square root 9. That's 2 times square root of 9. So I have 2 times 3. So I'm going to go one more step. What is 2 times 3? That gives me a 6. Okay, so my answer for that one is just 5 square root 3 divided by 3. I'm sorry, 5 square root 3 divided by 6. Okay, so just an introduction to rationalizing. I don't want to give you anything more complicated than that, just a little exposure. All right, thanks everybody. Hope you're well. Take care.